Good day, everybody. How are you all, friends? Today we are going to talk about test in standard deviation. Okay, so let's share my computer screen with you. A sample of heights in feet of active volcanoes in North America outside of Alaska is listed below. Is there sufficient evidence that the standard deviation in heights of volcanoes outside Alaska is less than the standard deviation in heights of Alaskan volcanoes, which is 2,385.9 feet? Use alpha level of significance of 0.05. And there are six heights of volcanoes outside of Alaska are given. So, solution. Okay. So this is a test in standard deviation. So null hypothesis and alternate hypothesis. So the alternative hypothesis comes from the stem of the problem. Is there sufficient evidence that the standard deviation in heights of volcanoes outside Alaska is less than the standard deviation in heights of Alaskan volcanoes, which is 2,385.9. So the null hypothesis is equal to standard deviation sigma, population standard deviation sigma equal to 2,385.9. Okay. Level of significance is given alpha is 0.05. My sample size n is sample size is 6. So my degrees of freedom is n minus 1. 6 minus 1 is 5. Okay. So first we will do press the second button of the calculator, then plus button, which is on top of the enter button on the bottom right corner, then select number 4 and enter. Okay. We will get clear all list in the calculator. We further press the enter button and it says done. That means memories of the calculator have been cleared. Of the TI-84 has been cleared. So let's do that. Second button. So I put the calculator on. Second button. Plus button on top of enter. Then number 4. Clear all list on the calculator screen. Then enter. Done. Memories of TI-84 has this should be have been. So let me erase them. '84 have been cleared. Okay. Now enter. So next thing we do is press the stat button. Then select number 1. So stat button, then number 1. And okay, stat and number 1. And we see L1. Enter. Next step is enter data in L1. And data in L1. Okay. So these are the heights of the volcanoes given to us. 10,777 is the first entry. Enter. Then the next entry is 8,159. Enter. 11,240. Enter. 10,456. Enter. 14,163. Enter. And 8,363. Enter. We did enter the height data in the L1 because we need to calculate the sample standard deviation. So the next step, let me move this a little bit, create some space. Next step, again, press the start button. Press the start button. Then highlight calc in the top row, that is move the cursor on top of calc. Then select number 1. So you have one var stat on your calculator screen, one variable stats. Okay. First line is list, which is automatically set at L1. Second line is frequency list, and it should be empty. Nothing should be there. If there is something, you bring the cursor on the second line and hit the clear button, which is in the third row of the calculator. Bottom line, nothing on the right of the colon sign in the second line, which is frequency list. And then calculate. Put the cursor on calculate and hit enter. Okay. So I told you we are interested in the sample standard deviation, which is SX, is the sample standard deviation. Standard deviation. Sx is equal to 2194.845. Okay. We need this standard deviation because we have to calculate the test statistic, which is a chi-square test statistic. Okay. So now calculate test statistic, which is chi-square, is equal to n minus 1 times s square divided by sigma square. Okay. Where sigma square, sigma is standard hypothesized population standard deviation. Population standard deviation. And it comes from 80. Okay. So this test statistic is called chi-square, not chi-square, chi-square. Okay. So our, let me create some more space. Maybe I'll reduce this a little bit. So if you notice our sigma, the hypothesized thing is sigma is hypothesized standard deviation, population standard deviation is 2385.9. Now I have to erase this 9. I don't know how I got this answer. Okay. So 2385.9. Okay. So let's calculate the test statistic first. Okay. So test statistic chi-square is equal to n. We have n as 6. So n minus 1 is 6 minus 1 times multiplied by Sx, as I told you, is 2194.845, and sigma is 23, that is the hypothesized value from the null hypothesis, and both of these are squared. Okay. So in our calculator, we will do chi-square is equal to 5 multiplied by 2194.845. Then press the x square button, which is in the first column of calculator keys halfway down, puts the exponent 2 on top of this, divided by, put a parenthesis, 2385.9, and then press the x square button again. This also puts an exponent 2 over here. So chi-square is equal to 5 multiplied by, in parenthesis, 2194.845, close the parenthesis, then press the x square button, divided by left parenthesis 2385.9, close the right parenthesis, then do not forget to press the x square button, because the standard deviation, hypothesized standard deviation in the denominator is also squared. That's why we need to press the x square button and then hit enter. So this is your test statistic, 4.231. Okay. Now let's take a look at the null and the alternate. Oops. So this will go over here. Test statistic. Okay, I wanted to move this. Basically, I wanted to show you this test, null hypothesis and alternate hypothesis. And notice this is a left tail test. Left tail test. Left. Erase this. Left. Tailed. Go back on this. Left tail test. And okay, alpha is 0.05. So let me now move up. Okay. So let me draw the picture of the chi-square distribution. Okay. Remember, my degrees of freedom is 6 minus 1 is 5. Okay. So chi-square distribution looks like this. Okay. So this is probability on the vertical axis and chi-square on the horizontal axis. Now my level of significance alpha is 0.05. This is a left tail test. Okay. That means we need to find this chi-square critical value from the table. Chi-square critical, such that the area to the left of it, this area is 0.05. Okay. Now if I move up a little bit more, okay. So Just wanted to remind you, area in the left tail is 0.05. Area in the right tail, which is not shaded, is 1 minus 0.05, which is 0.95. Why do I need the area in the right tail? Because when I go to the chi-square table from the textbook or from the website which I have listed before, is we will get degrees of freedom in the first column. So we have 5 degrees of freedom. So in the first column, we'll first look at 5. Okay. Then in the top row, we are interested in area. The top row is always area in the right tail. In this case, area in the right tail is 0.95. So this column 0.95, we draw a vertical line. Degrees of freedom, we draw a horizontal line. This is your critical value where the horizontal line through 5 degrees of freedom and the vertical line through 0.95 intersects. Okay. So you can go to the website or you can use a textbook, for example, which lists the chi-square values. And let's see, chi-square values. Okay, so my degrees of freedom is 5. My area in the right tail is 0.95. The critical value, the intersection point for horizontal line drawn through 5 and the vertical line drawn through 0.95. This critical value over here is 1.145. Okay, so this critical value is 1.145. Okay, is critical value is chi-square critical. Okay, our test statistic chi-square is equal to 4.231, which is greater than 1.145. That means it falls in the area which is not shaded. Therefore, decision is decision. Since 4.231, which falls somewhere over here, maybe over here, 4.231. And the critical value is 1.145 is over here. Okay. So 4.231 is greater than 1.145 and it is in the non-shaded area where the decision is do not reject H0. So conclusion is at alpha equal to 0.05, there is not enough evidence to support HA. Evidence to support HA. Okay. So let's check on that. Okay. I'm checking the answer out, making sure it's correct. Yep, critical value is 1.145. Our test statistic is 4.234. Decision is do not reject H0. And the reason is it falls in the unshaded area because 4.231, the test statistic, is greater than the critical value of 1.145. Therefore, decision do not reject H0. Conclusion, at alpha equal to 0.05, there is not enough evidence to support HA. Now let me see if I have the address of the website where you can get the chi-square. So let me move this up a little bit. Okay. So I will write website to get chi-square. To get chi-square, critical is I have the address. It is https dot slash double slash forward slash people dot richland richland dot edu forward slash James. This is the last name of the person who has created this table. Slash lecture slash M170 must be the course number, and then forward slash TBL, short form of table, dash CHI for chi, and then dot HTML. Okay. So this is the website to go to get the critical chi-square value to solve this problem. I will stop here today. If you have any question, comment, please write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. Please share this video with your friend, and you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And I'll see you next time with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day.